Octave also has some advanced visualization methods for displaying matrices as images or doing surface plots or contour plots. So let's look at that. So this example shows just well, actually, let me type it in, and uh, I'll take a look at. So what we're doing here is actually just first forming a 100 by 100 image. It's actually taking the vector 1 by 10,000 and then just reshaping it into a 100 by 100 matrix. So the first element of this matrix will be 1, and then the last element of this matrix will be 10,000. So the matrix, just if we look at the first 10 elements, they're just the numbers 1 through 10. Or if I look at the submatrix, the upper corner of it, so again, the first column actually goes 1 to 100, then the second column 101 to 200, and then so on and so forth, and then there are actually 100 columns. This is just showing a portion of this. So we've got this matrix with elements that go from 1 to 10,000. When we can actually use the image scale command to display the image actually as image to display the matrix as an image. Okay, and so this is the result. Now if you'll notice, actually here this is using a different color map than is what's used in the slides. Octave and MATLAB have changed their default color map. I'll change it in just a second so it looks just like the image on the slide. But then the next thing to show is the corresponding color bar. So we could do that with just typing in color bar. And now if we go look at the plot, the corresponding color bar shows here that values in the matrix that are 0 are shown as this kind of purple color, and then values that are shown at close to 10,000 are shown as this yellow color. And then it runs the spectrum in between. So if you'll remember, our first element, our 1, 1 element, is up here. It's going to be the darkest color. Then the values go 1 to 100, 101 to 200, so on and so forth, until we get out here, and this last value is 10,000. So what Image SC has done has automatically scaled the matrix so it shows up as this kind of pseudo color image using this particular color mapping of numbers in the matrix to colors. And so this scaling is done automatically. It's kind of interesting. There are other color maps available. We can change the default color map used to be this jet color map. So I can change it so so the colors show up in this jet scale. Again, it's really a pseudo color mapping with the one element showing up as the darkest blue, and then this the highest element in the matrix showing up as this dark red color. This is called a pseudo coloring. The other thing we could do here is actually just show this using a grayscale mapping. It's not as interesting, certainly, but here the lowest value in the matrix corresponds to black, and then the highest value in the matrix, of course, the 10,000 value shows up as white. So let me go back to the jet mapping, just because it makes the data look a lot more interesting than it actually is. But you can use this Image SC to kind of show any matrix as an image. I will, I guess, mention that you can actually load any type of image. There's an imread function, and I just happen to have an image in this directory. And then here, this is a regular image, so it doesn't need to be scaled. We could take a look at this is a color image. And if you take a look at that, this is what that looks like. So you can actually do image processing with actual photos you might take from your camera and so on and so forth. So you can change the color map. I demonstrated how to do that. The color map is just a set of, and if I just call color map by itself without passing an argument, it will display the current color mapping, which in this case, again, these are the RGB values for each of the different colors that are available in this color map. In this particular color map in the jet, the last value has a lot of red and green and not much blue, and then it starts out with actually kind of low values for all three, but showing kind of a more blue than anything else in the current color map. Okay. But you can define your own color maps, knowing that the color maps are actually just 3-column matrices with 256 elements, or actually color maps can be of different lengths, but 256 or 64 elements in a color map are kind of standard. Okay. A little more interesting than images are actually surface plots. So, this is a three-dimensional surface above an XY plane. So an example function that you might see from a math class is a function of two variables here, and we want to plot this for x between minus pi and y between minus pi and pi. So, and typically, when we do this, you can use the surf function to do that. What we need to do is lay out this grid in the XY plane that has all the coordinates of the XY points, and then the corresponding Z value above that point. So the easy way to do that is actually using this mesh grid function to make these X and Y matrices. Typically, our X and Y values are laid out on a rectangular grid, and so the X value, for example, doesn't is just repeated along the entire, as we go along the y-axis, and similarly, the y value is actually just repeated everywhere along, for a particular value of x, and so we just need to replicate that value, and that's what mesh grid does for us. And then z here, this line will actually compute the product then of sine of x. X is a matrix now, so sine of x will be a matrix of values, and so we multiply that by cosine of y to get that product, and then we just pass to the surf function x, y, and z. Instead of typing all that in, I've already got it entered into a script called surf example here, that just shows the values on that were on that slide. And I changed the color map to the same color map that was used on that slide. So if I run this, okay, we get this kind of interesting looking surface. Again, in this default color map, dark values are low values are blue, and then the higher values are red. And I can actually add a color bar to this as well, just by typing color bar. Will add this bar to the figure showing the mapping between the color values and the corresponding colors. Now here, it's the product of the cosine and sine, and the range of product values actually varies between -1 and +1. And so surf does this scaling automatically. And there are a lot of different, I can change this plot in a lot of different ways. One of the interesting things I can do here is if I select this rotate tool, I can actually rotate the figure around and look at it from different perspectives, okay, which is kind of neat. I can actually get a top-down view, so it looks like a two-dimensional figure when viewed from directly above, or I can look at it from underneath, or spin it around and look at different interesting features in the graph. you can again do help surf to see all the different uh, options that are available. You can get rid of the grid lines and again show this as with different color maps. Different shadings are all possible. Okay. Um, uh, in addition to um, a surface map, we can show it as a mesh, which actually is, you know, the wire mesh. It won't be shaded. The little regions between the lines here won't be shaded. Actually, the easiest way for me to do that is actually just change my code here from surf to mesh and rerun it. So you'll see the difference now. Previously, the little areas between the grid lines were all colored. Now they're see-through, and we just see the mesh grid. Again, it's still colored according to the current color map. We can also do contour plot. Okay, and again, probably the easiest way for me to do that is just to go back and change the mesh to a contour and replot. Okay, then this is a contour plot showing lines of equal value in that surface, that XY surface that we have. And then, you know, I can even make things like I can do a hold and show a mesh plot above a contour plot if I want. Okay. So here's another exercise: modify plot sign to do the following. If two inputs are given, evaluate this XY function and plot it. Y should be just like X, but using F2 instead of F1, and then use and then actually display an image of the Z matrix in the top of the subplot, display the color bar, and use a hot color map. And the bottom axis of that subplot, plot the 3D surface of Z. So let's see. So display it as an image in the top subplot, and display it actually as a surface and the bottom subplot. I'm going to skip through this. You know, if you want to take some time to actually play around with this, you know, the slides are online. So if you want to pull up the slide to see what code actually does that, I'm going to skip this. But this is the resulting figure you should get with a plot sign 3,4. You know, showing the image of the surface in the top subplot, and then showing this surface using a surf command in the bottom. Okay, there are a bunch of other specialized plotting functions for polar plots, bar graphs, quiver plots that show vectors, stairs. You can actually do fills and lines. There are commands to actually add text to graphs. Again, a whole bunch of different things for doing some really interesting stuff. You can even do a complete course in image processing, and there are even video processing functions available for processing video. Okay, one more short video to complete today's lecture, but I'm going to wrap up this video.